Hello. In this video, we're going to look at what are called one-variable statistics. And there's two different types of one-variable statistic. We have measures of central tendency, many of which will be familiar to you, and measures of dispersion, which are probably new. So to start, we're going to look at the 8 numbers that are listed here. So 3, 4, 4, 6, 8, 12, 15, and 20. And we are going to run one-variable statistics on our calculators on these numbers. Depending on your calculator, it's going to be run differently. So I have posted in D2L some links to YouTube videos that will walk you through how to do this on a TI calculator and on a Casio calculator. So once we've done that, we get a certain amount of information. So we're going to initially start with mode. Mode actually isn't something our calculator tells us. That's something we see by looking at the data. So the mode is the most frequent data point, which in this case is 4. It's possible for data to have no mode. So if all of the outcomes are equally likely, for example. And it's possible for data to have more than one mode. So if I had, let's say, 2 4s and 2 15s, then the modes would be 4 and 15. This would be bimodal data. But in this case, we have a mode of 4. First quartile, median, and third quartile all kind of come from the same thing, and our calculator does tell us what they are. So in this case, the first quartile is 4, the median is 7, and the third quartile is 13.5. Where these are coming from, so the median is the middle data point. Now, in this case, where the middle of the data is between 2 points, the median is the number that would be exactly halfway between them. So I have 4 numbers in the first half, 4 numbers in the second half. Halfway between 6 and 8 is 7, and that's why the median is 7. The first quartile is essentially the median of the first half of the data. So the median goes in there. The first quartile, which we often will just call Q1, while halfway between 4 and 4 is just 4. And the third quartile would be the median of the second half of the data. In a way, you can think of the median as being the second quartile, because 2 quarters is basically a half. And halfway between 12 and 15 is 13.5, so that is why that is the third quartile. The mean is calculated by adding up all of the values, so the sum of all of the values divided by however many of them there are, which in this case, again, the calculator tells us what it is, although you certainly could add them all up and then divide by 8. In this case, because it's not a crazy number of numbers, symbols for the mean can be an X with a bar over it, or the Greek letter mu. And in this case, the mean of that data is 9. There is a distinction, technically, between when we use which of these two symbols. So when we use the X with the bar versus when we use the mu. It's a difference between, is our data the whole population or is it just a sample? But for our purposes, we are going to treat them as interchangeable. When you get to a university statistics course, they will be a little pickier about whether you use one symbol or the other. But for us, we're going to use them back and forth. So these are measures of central tendency because they tell me a little bit about the middle of the data. Measures of dispersion, on the other hand, tell me how the data is spread out. So the range is just going to be the maximum value minus the minimum value. So in this case, the maximum is 20, the minimum is 3, so this data has a range of 17. The interquartile range is the difference between the third quarter and the first quarter. So the range between the quartiles. So in this case, 13.5 minus 4, or 9.5. And the standard deviation, now we also have a couple of symbols for standard deviation. We are going to mostly just use this one. And our calculator tells us what that is. In class, we'll go over how the standard deviation is calculated and sort of what it means a little bit. But in this case, we get about 5.7 as the standard deviation. Just as a quick kind of rough explanation of what a standard deviation is, it's sort of the average distance from the mean. So deviation meaning difference between a value and a mean, standard being kind of another word for average. So standard deviation is essentially calculating what is the average distance between data points and the mean. So a larger standard deviation will mean that the data is more spread out. A smaller standard deviation will mean that it's much closer together. We will spend a fair bit more time on standard deviation. But I want to get back to a graphical representation that sort of uses the basic concepts of central tendency and dispersion. And this is what's called a box and whisker plot. So box and whisker plot, which uses a box to represent the middle of the data and whiskers to represent the spread of the data. So for a box and whisker plot, we use a number line. And on that number line, we need our minimum value, which in this case was 3. So I'm going to go to 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, because 20 was our highest value. So on the box and whisker plot, we mark our minimum and our maximum values. We are also going to find what are called outliers, but we'll do that in a moment. Then we use our first quartile, our median, and our third quartile. So the first quartile in this case was 4. So the median was 7. And the third quartile was 13 and a half. Those 3 lines form the box. So the outside edges of the box are Q1 and Q3, with the median marked as a line inside the box. And the minimum and the maximum form the edges of our whiskers. So we connect it here with these lines. So this sort of helps me to see the data a little more visually. For example, I can see that half of the values should be below the mean. So what I see is that that half is grouped in a much smaller space, whereas the upper half of the numbers are much more spread out. And half of the data is found between Q1 and Q3. So half of the numbers are inside that box, and the other half will be out along on the whiskers. So this sort of helps me see a visual representation of the spread of the data, while also marking where the middle of the data is. So let's talk a little bit about outliers. First variance. Variance is the standard deviation squared. So in this case, that would be the 5.7 squared, roughly. We use variance a lot less, but it does show up in some things. Standard deviation is the one we care about more. All right, so there's a couple different ways to think about outliers, but we're going to use the outlier definition that uses what's called the interquartile range. So the interquartile range, which I'm going to call for shorthand IQR. So the outliers are any value below or less than Q1 minus the 1.5 times the interquartile range, or bigger than Q3 plus 1.5 times the interquartile range. So in this case, our interquartile range was 9.5. So my Q1 was 4. So then minus 1.5 times 9.5. And Q3 was 13.5. So plus the 1.5 times 9.5. So that means that in this case, I would have an outlier if I had a value that was less than, so this right here is negative 13.25, which we don't have. We only have positive numbers here, so we don't have any low outliers. So an outlier would be a number that's so far away from the rest of the data that it strikes us as odd. It stands out. And 13.5 plus 1.5 times 9.5, which gives us 27.75. So again, we don't have any numbers that are that high. So in this particular example, we have no outliers. If we did have outliers, we would essentially mark them on our box and whisker plot, and we would be more likely just to extend the whisker out to 1.5 times the interquartile range. In other words, my whisker would only go out to the 27.75, and any outliers I would mark with an X outside of that. But in this case, we don't have any outliers. All right, so let's look at these two groups with different quiz results. And let's think about what it is that standard deviation basically tells me here. So if I look at this and I say, okay, well, 50, 50, 50, if I think about what the mean of that data would be, it's going to be exactly halfway between those scores. So the mean of that data would be 75. which is pretty reasonable. I think most of us understand why that would be the mean, and you know how to calculate the average. So the mean here would be 75%. A little less standard, but remember I told you that standard deviation kind of means the average distance from the mean. So if I look at all of these numbers, they are all 25 away from the mean. Above or below doesn't really matter. And that does end up being the standard deviation here. The standard deviation is 25%, because on average, if I took a data point, it would be 25 away from the mean. Half of them are above, half of them are below, but they're all 25 away. This second group, on the other hand, where everybody got 75%, that obviously is the mean again. In this case, my standard deviation is going to be 0. So that really, I think, starkly illustrates the difference between these two groups in terms of standard deviation, and it explains why we need measures of dispersion. Because if all I were to give you were the measures of central tendency, the mean and the median actually for both of these groups are 75. But that doesn't really tell us the story of the differences between these groups. They can have the same mean, but the standard deviations are wildly different because the distributions are wildly different. In fact, in general, if the standard deviation is 0, what that means is all the data points are the same. All data values are just the mean, because there is no deviation. There's no difference between the mean and any of the actual values.